Good evening, class. We are looking at Chapter 2 review, limits and derivatives. Exam will cover from 2.1 to 2.8. Here's the third part covering 2.7 and 2.8. Derivatives and rates of change, the derivative as a function. So first, the derivatives and rates of change. Given the function y equals f of x and point P with coordinates a and f of a, the slope of a secant line PQ is the average rate of change. So you have 2 points on a curve, you connect it, you draw a line, it's called a secant line. To find the slope, which is the average rate of change, delta y over delta x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is the definition you've seen before from elementary algebra. 2 points, we can calculate this. There are other ways of writing that. For example, if we look at these two pairs, now we write f of x minus f of a over x minus a. That's the same thing. If we look at this graph, now it's f of a plus h minus f of a over a plus h minus a, which makes it h. These two are normally referred to as the difference quotient. Now, if we say this point has coordinates b, f of b, it becomes f of b minus f of a over b minus a. Meaning, they all refer to the same thing, rise over run. This blue line that connects 2 points of the graph is called the secant line, PQ. Now, as we move Q towards P and we get closer and closer to that, eventually it gives rise to the red line, which is the tangent line. The tangent line is the limiting position of the secant line PQ as Q approaches P. A tangent line is a line that touches a curve at a specific point without crossing it. Slope of a tangent line, also known as instantaneous rate of change. The average rate of change, you have 2 points to calculate the slope. Instantaneous rate of change, you have only 1 point, and there are different ways of approaching it. M, the slope of the tangent line, the red line, is the limit of M of PQ. It's the limit of the slope of this blue line, the secant line PQ, as Q approaches P. So as you can see, look at this line, and then this one, and then this one, they're getting closer and closer towards P. If we look at this one, as x approaches a, so the limit of f of x minus f of a over x minus a as x approaches a, if we look at this. If we look at this one, as this distance becomes closer and closer to 0, so would be the limit of f of a plus h minus f of a over h as h approaches 0. This is the slope of a tangent line M or f prime of a. There are two different ways of approaching it. And we are interested in finding equation of lines. We remember the standard form is ax plus by equals c. Point slope is y minus y1 equals m times x minus x sub 1. Slope intercept is y equals mx plus b. Now, if we want to find the equation of this red line, this tangent line, here's the point P, which has coordinates a, f of a. And to find that, we just follow this point slope y minus y1 f of a equals m, which is f prime of a, times x minus x sub 1, which is a. Now, do I have to memorize this formula? I guess not, because I'm assuming everybody knows the point slope. Just follow the point slope. Let's get started with a simple example. Find the derivative, aka instantaneous rate of change of f of x, of the function f of x equals x squared minus 8x plus 9 at x equals 5. So we are interested in f prime of 5, which means we are going to follow one of these formats. This is more common. So we want f prime of 5, the limit as h approaches 0 of 5 plus h minus f of 5 over h. Now, you can work on this fraction, simplify, and then apply the limit. Or you can just keep up with the limit. At the end, when you want to apply it, it's important to have this limit. Now, what is f of 5 plus h? That means 5 plus h squared minus 8 times 5 plus h plus 9. What is f of 5? Plug in number 5. So the limit as h approaches 0, a large fraction bar, the denominator is h, 5 plus h squared minus 8 times 5 plus h plus 9, and this is minus 5 squared minus 8 times 5 plus 9. Now, we remember a plus b squared is a squared plus 2ab plus b squared. So 5 plus h squared is 25 plus 10h plus h squared. This is minus 4d. This is minus 8h. This is plus 9. Now, we can simplify this or just use it the way it is. Minus 5 squared, 25. Minus 8 times 5, minus 4d becomes plus 4d. And this one is minus 9. The reason I did it this way rather than simplification, the proper way is to simplify this and then apply that. Because I want you to see the following, everybody. These two cancel each other. These two cancel each other. Also, these two cancel each other. So what are we left with? 10h plus h squared and minus 8h. These two add up to 2h. You factor the h out from the numerator. H drops from the top and the bottom. Now, this is what I mean. This is important. At this step, you must have this limit. If you don't have the limit, the answer is 2 plus h. Now that you have the lim sign as h approaches 0, you replace it, and the answer is 2. Of course, later on, when we use formulas, it becomes much faster and easier. But for now and for this exam, we must use the definition. We're going to practice with a couple more exams. And again, I'm reminding you that we have to go with the definition. It can be a lot easier when we use the formula. So plug in for this one. We want f prime of x. Now, the derivative function, this is now f prime of x, which is the limit of f of x plus h minus f of x over h as h approaches 0. And in this case, we are going to write this one for this function f of x. So f prime of x is the limit of a 5 times x plus h plus 1 minus this function over h. So this piece is f of x plus h. Five x plus 5h plus 1 minus 5x minus 1. 5x and minus 5x cancel each other. Positive and negative 1 cancel each other. The numerator is left with 5h only. The limit of 5h over h as h approaches 0, the h drops, and the answer is 5. We do the same thing here. We write f prime of x is the limit as h approaches 0, fraction bar at the bottom is h, at the top f of x plus h is 2 over x plus h. This is f of x plus h, and of course minus f of x is 2 over x. As you can see, you're dealing with a complex fraction. Needless to say, if you plug in, you get 0 over 0. The technique for complex fraction is to use LCD, the least common denominator, which is x times x plus h. So first, the denominator. Remember, h is approaching 0. This is the problem. You don't do anything. You keep it as a product. The numerator, if you multiply these two, x plus h drops, you get 2x. If you multiply these two, x drops, you get 2 times x plus h. Don't forget the sign minus. So again, the product of these two is this. Okay, everybody? And the product of these two is this. Okay. All right. So in the numerator, we have 2x minus 2x minus 2h. Two x and minus 2x cancel each other. And now we are left with negative 2h in the numerator. Remember, the problem is always the h in the denominator. Now we have a way to cancel it out. So we get the limit of negative 2 over x times x plus h as h approaches 0. And now when you replace it, you get x here. X times x is x squared. The answer is negative 2 over x squared. F prime of x is negative 2 over x squared as the final answer. Find an equation of a tangent line to the graph of the function f of x equals square root of 3x plus 1 at x equals 0. When you want to find an equation of a line, you need a slope and you need a point. They can give you a pair x comma y, or they may just give you x. If you plug in, you get the y coordinate. When we plug in, we get 3 times 8, 24, plus 1 is 25. Take a square root, and the pair becomes 8 comma 5. We also need the slope. To find the slope, we take the derivative. So we go with the definition, f prime of x, and then at the end, plug in 8. So f prime of x is the limit as h approaches 0 of f of x plus h. which makes it square root of 3 times x plus h plus 1 minus f of x, the same thing over h. So you get this one. Again, if you plug in, you get 0 over 0. Because you're dealing with the square root, the technique is the conjugate. So the conjugate would be the same thing with the plus sign. You're going to multiply and divide by it because this expression is equal to 1. So that is acceptable. So the result is a squared minus b squared. You square this part minus you square the second part. So we get the first one squared up, put it up here. So square root of 3 times x plus h plus 1 squared minus square root of 3x plus 1 squared. So each one just comes out. This becomes 3 times x plus h plus 1 minus this becomes 3x plus 1. So all we have to do is distribute 3x plus 3h plus 1 minus 3x minus 1. Three x and minus 3x, positive 1 and negative 1 cancel each other. And we are left with 3h in the numerator. The h drops. Now we can apply h equals 0. When we do that, this becomes square root of 3x plus 1. Therefore, we have two of those now. And f prime becomes 3 over 2 square root of 3x plus 1. We want the slope at x equals 8. We plug in, remember when we plugged in 8, we got 5. So this is 5, 3 over 2 times 5. M is f prime of 8 is 3 over 10, and the pair is 8 comma 5. Y minus y1 equals m times x minus x of 1. So y minus 5 is 3 over 10, x minus 8. 3/10 times x minus 8. So we are going to distribute. This is 3/10 of x. The product of these two is negative 24 over 10, which is negative 12 over 5. We move the negative becomes positive 5, which is 25 over 5. And y becomes 3 over 10x plus 13 over 5. And you can always plug this in. When it works, it means this process has been done. It doesn't say anything about the differentiation. The graph of a function f is given in the figure. Use it to sketch the graph of the derivative f prime. To do so, by the way, use it to sketch a rough graph, okay? The way to do this is to look at the easy points. Peaks and valleys are the relative max and mean, where f prime is 0. If you look at this point, this point, this point, this is a relative mean, relative max, relative mean. And the function is decreasing here, decreasing here. If you think about it as, if you imagine it's a line, use looks like a line with a negative slope. This portion is increasing, this portion is increasing. So we use this information. Relative maximum mean f prime is 0. When f prime is positive, f is increasing. When it's negative, f is decreasing. So first and foremost, those three easy points, they correspond to 0 for y equals f prime of x. So A prime, B prime, and C prime. Those 3 points, you see the horizontal tangent line, indicate that with the same x coordinate, their y coordinate for f prime of x must be 0. Let me quickly explain how they came up with that, and you don't have to worry about it. They're just drawing a tangent line, and they pick 2 points, and they do their best to calculate the slope. And notice it says an approximation, which means on the graph of f prime of x, there is a point with the same x coordinate, 5. The y coordinate is m, which is 3/2. That's the meaning of it. Now, so let's concentrate on those 3 points and what happens in between. Okay, the function is decreasing here, increasing here, decreasing here, increasing here. So let's look at the decreasing part. And first, in between, notice at B we get 0, at C we get 0, and decreasing means f prime is negative, so it has to go below the x-axis, but it has to come back up, back to 0. So it's, for this part, it'll look something like this. Again, it is definitely not to scale, but you get the picture. For this part is just below the x-axis because it's negative. Same thing for the increasing part. First, I want to look at this part. It's between A and B. So between A prime of B prime, and it has to come back to 0. And then this part, increasing, is somewhere up. And this specific point has coordinates 5 and roughly 3/2 or 1.5. So that's the way you do the graph. And of course, this is a more precise answer, and I'm going to erase my work. That's how you arrive at it. And let's start with the simplest example. This is a line. And you know, when we discuss the derivative, because in this example, it says the graph of a function is given, use it to sketch the graph of the derivative f prime. The derivative is the slope. All you have to do, calculate the slope, rise over run. And to do so, you pick up 2 pairs. Obviously, this is 0, 0. And then this point is 1, 3. Please understand that the scale along the x-axis is different than the scale along the y-axis. This is 6, so that makes this 1/2 of it. And so the slope is 3 minus 0 over 1 minus 0, or simply 3. And the way you come up with the answer for any line, you say the answer is a horizontal line with an equation y equals the slope. So y equals 3. So if the slope was 2, y equals 2. If the slope was negative 1, y equals negative 1. And that's the graph, and you're done. Well, what about this one? Again, look at peaks and valleys, the EZ points. At those points, same x coordinate, the y coordinate is 0. First, we look at the decreasing. In between is decreasing. So in between, it goes below, and it has to come back up at some point below the x-axis back to 0. The other two parts are increasing. This is increasing above the x-axis. This is also increasing above the x-axis. Put them together, that's your graph.
Professor, I don't mean to interrupt, sorry. I was wondering where I can find the password for the exam.
Now we have this graph. Again, we look at the EZ point. As you can see right here, we have a horizontal tangent line. It's a peak, therefore it corresponds to this point. Same x coordinate with the y being equal to 0. This portion of the graph is increasing. This portion of the graph is decreasing. So for the increasing part, it's above the x-axis. And for this part is below the x-axis. Putting them together, you get the graph looking like that. Bear in mind, it doesn't have to be perfect. As long as you have some idea, you should be able to handle the question. How can a function fail to be differentiable? There are three ways. One, if there is a corner, a sharp corner. Two, a discontinuity. Three, a vertical tangent line. So a corner or kink, the graph of f has no tangent line at this point. The left and right limits are different. So the point is, or the question is, where do you draw the tangent line? Discontinuity. If f is not continuous at a, then f is not differentiable at a. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. The limit of the absolute value of f prime of x as x approaches a is infinity. We're talking about the vertical tangent line. As you recall, we always said a vertical line has a slope which is undefined. But actually, it's really not. It tends infinity or negative infinity. And so the graph of a function f of x has a vertical tangent at the point a comma f of a, if and only if. Everybody remembers that this means you can move to the left or right if and only if the limit of f prime of x as x approaches a is negative infinity or positive infinity. In other words, both sides have the same result, one of those, infinity or negative infinity. However, cusp, both sides don't have the same result. One side is positive, one side is negative infinity. For example, in this graph, as x approaches 0, the limit of f prime of x as x approaches 0 from the right is infinity, but from the left is negative infinity. So cusp, when the graph of the function becomes vertical and then virtually doubles back on itself. Such pattern signals the presence of what is known as a vertical cusp. In general, we say that the graph of f of x has a vertical cusp at a, comma f of a. If the limit of f prime of x as x approaches a from the right is infinity, from the left is negative infinity, or vice versa, both sides do not have the same result. Let's look at a simple example to make some sense out of this. We want to see the given the graph of a function, where and why the function is not differential. We start, obviously, the first one clearly right here at x equals 0, we have a discontinuity. The next one, at 3, we have a vertical tangent line. Now I'm going to distinguish between a vertical tangent line and a sharp corner in a moment, but if you think they seem to be the same, that's okay. It's not that big of a deal. The next one, obviously for this function, we have a discontinuity at -1. And then at 2, clearly we have a sharp corner. Now, again, what's the difference between a sharp corner and a vertical tangent line? I hope you notice that this shape is a V shape, or if it's a V shape upside down, whereas this one clearly is not V shape, it's moving up, and therefore it has a vertical tangent line. The graph of a function f is given. Use it to sketch the graph of the derivative f pi. First, notice we have 1, 2, 3, 4 line segments. So we are going to deal with 4 lines in essence, and all you have to do, find their slopes. First, let's throw in some numbers, and normally it's very clear what those points are. In this case, if it's not, don't worry about it if you come across a question similar to that on the exam. So this one is -3, 1, this one is -1, 0, and the rest of it. So for this one, just like any other one, we are going to calculate the slope using rise over run. So this becomes 0 minus 1 over -1 minus -3, which means the slope is -1/2. You may realize if the slope is -1/2 here, this must have a positive slope, m equals positive 1/2. This is easy to see. 1 minus 0, 0 minus -1. The slope is positive 1 for this one, -1 for this one. So first we calculate this. We want to concentrate on the first one again. Notice if this line continued indefinitely, then we wouldn't have a line segment or a portion of a line, and the graph of its f prime has the equation y equals the slope. Y equals -1/2. And the same thing for the rest of it. This one, y equals 1. This one, y equals -1. This one, y equals 1/2. So this one covers this portion. So from here to here, we can have a line y equals -1/2. And we have a hole at the end because there's a sharp corner here, here, and here. So at each endpoint, we get a hole. For this part, we get y equals 1, this portion, and it looks like that. For this one, we get y equals -1, this portion. And for this one, we get y equals 1/2. Notice the endpoints. There's a hole here, hole here, hole here, and so on. Okay? That's how you graph them. The arrows that I have here, none of them is part of the graph. I'm showing you for here, for example, we cover this much along the x-axis. Find the limits. The limit of the square root of 1 plus 4x to the power of 6 over 2 minus x cubed as x approaches -infinity. The different techniques, one easy way is to notice that, imagine if it had x to the power of 6, somehow it could come out and become either x cubed or minus x cubed. We're going to discuss y positive or negative in a moment. And then that would make life easy. So take x to the one way is to take x to the power of 6 out inside the radical sign. When you take this one out, this becomes 1 over x to the power of 6, and this becomes 4. Now, I want to bring x to the power of 6 out. To do so, what do I get? X cubed or negative x cubed? Which one and why? Let's discuss that. In case of a limit as x approaches positive infinity for x larger than 0, remember, square root of x squared is always absolute value of x. If we know it's positive, we can drop the absolute value. So square root of x squared always equal to absolute value of x. In this case, because it's positive infinity, is x. If x approaches negative infinity, it is still absolute value of x, but this time is minus x. Minus x does not mean negative. It means the opposite of x. And because x is negative, actually this is positive. Okay? So for x being less than 0, that's what we use. For x being larger than 0, that's what we use. X is larger than 0, drop the absolute value. X is less than 0, write its opposite. Therefore, square root of x to the power of 6 is x cubed for x larger than 0, and minus square root of x to the power of 6 equals x cubed, or square root of x to the power of 6 is minus x cubed for x less than 0. So if you want to take this out, you have to write minus x cubed. And I'm writing the sign in a different color, so it becomes clear that you need the negative sign out there. Now, when x approaches infinity or negative infinity, what is the technique? By the way, if we go back here, I hope you recognize when you plug in, it becomes positive infinity. Square root is positive infinity, 2 minus negative infinity. So you get infinity over infinity. So the technique is divide by x cubed or multiply by 1 over x cubed. So this drops from the top. This becomes 2 over x cubed, and this becomes negative 1. So we drop the x cubed from the top. The bottom becomes 2 over x cubed, and this one becomes negative 1. Now, if you let x go to negative infinity, this goes to 0, this goes to 0. Minus square root of 4 is minus 2. This is negative 1. The result is positive 2. This is a question you want to look at the recording a couple of times to be on the safe side. Okay, everybody? Find the limits. The limit of x squared over square root of x to the power of 4 plus 1 as x approaches infinity. And I'm reminding you of what we discussed in the previous page. And so what happens here is similar to that, meaning the methodology, if you plug in, by the way, you get infinity over infinity. Okay? The methodology is that I'm going to take the x to the power of 4 out. Before I take it out, I'm going to factor it inside, which gives me 1 plus 1 over x to the power of 4. Please notice if I distribute, I get this one. How do I take this out? Well, this is x squared. Square root of x to the power of 4 is x squared for x larger than 0. Because x is approaching infinity, that means positive. Okay. Now, x to the power of 4 is something interesting, different than x to the power of 6. Because 4 divided by 2 is 2, and this is even. Even in the case of less than, it becomes still positive. Okay. Because x squared is still positive. Whereas x cubed, if the value of x is positive, it's positive. If the value of x is negative, it's negative, okay? That goes back to elementary algebra. So with that being the case, we can take x to the power of 4 out and call it x squared. You can drop this 2, and the numerator changes to 1. Now, if you let x go to infinity, this goes to 0. When this goes to 0, you get 1 over 1 or 1. So is there a couple of questions that are interesting? You want to perhaps look at them one more time. Find the derivative of this function. Again, we are going with the definition, everybody. So we're going to put it into this formula. F prime of x is the limit as h approaches 0 of fraction bar h at the bottom. F of x plus h means 7 times x plus h quantity squared plus 4 minus 7x squared plus 4. We've done this many times before. This is x squared plus 2xh plus h squared with the 7 in front of it. When we distribute, we get 7x squared plus 14xh plus 7h squared plus 4 minus 7x squared minus 4. Seven x squared minus 7x squared cancel each other. Positive 4, negative 4 cancel each other. This is left from the numerator. Now, I'm going to take the h out from the numerator. Only h. Can the proper factoring is to take 7h out. I don't want to do that because the h in the denominator is a problem. We want to get rid of it. If you did, it makes no difference. You will have a 7 here, 2x here, and h here. That works. And now, the limit of 14x plus 7h as h approaches 0, if you apply, you get 14x. Don't lose your limit sign unless you want to simplify this and then at the end again use the limit sign 14x. Example 30. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 40, where t is time in seconds. What is the average velocity of the object from 2 to 4 seconds? When they give you 2 points in time, that means average even if they don't mention it, which is simply total distance over total time. That's the v of average. And in this case would be s of t sub 2, that means s of 4 minus s of t sub 1 or s of 2 over t sub 2 minus t sub 1, 4 minus 2. We're going to put 4 into this function, 2 into this function. The denominator simply becomes 4 minus 2 equals 2. So for 4, we get 2 times 4 squared minus 5 times 4 plus 40. For 2, we get 2 times 2 squared minus 5 times 2 plus 40. Four squared is 16 times 2, 32, minus 20, plus 40, adds up to 52. 2 squared, 4 times 2, 8, minus 10, plus 40, they add up to 38. So 52 minus 38, it's 14 divided by 2, which is 7 feet per second. By the way, as far as the units are concerned, units of the numerator over the units of the denominator. The numerator, the change in feet over the change in seconds. What is the instantaneous velocity of the object at 4 seconds? Even if they don't mention instantaneous, one point in time means that. So we follow the formula. The V instantaneous is the limit of S of A plus H minus S of A over H. We are going from the limit of F of X plus H minus F of X over H to S of A plus H minus S of A over H. And now you are going to replace the A with 4. And we're going to develop this. And this one, we don't do anything because it's been done. We are going to use the 52. But what is this? 2 times the 4 plus H squared minus 5 times 4 plus H plus 4. 4 plus H squared is 16 plus 8H plus H squared multiplied by 2. You get 2 times 16, 32, plus 16H, plus 2H squared, minus 20, minus 5H, plus 4D, minus 50. Now, I hope you can see that 32 and negative 20 and positive 40 and minus 52, they all add up to 0. So what we have left in the numerator, 16H plus 2H squared minus 5H, and these two add up, we get 2H squared plus 11H. That's the numerator. And so take the H out. And now if you plug in the limit of 2H plus 11, as H approaches 0, if you plug in, you get 11 and the same units, feet per second. Find an equation of a tangent line to the parabola y equals x squared at point P with coordinates 1, 1. Again, you can find f prime of x and then plug it in. But we've discussed these two formulas, and I'm going to first use one of them and then the second one for practice. You don't have to go both ways. So in this case, A is 1, the x coordinate, and of course, f of x is y equals x squared. And I hope it's clear to everybody that we need to calculate this slope. So if we go with this formula, again, for practice, I'm going to do it because I want you to be exposed to both. You basically replace the f of x with, and A is, by the way, 1, okay? So m equals f prime of 1 equals limit of f of x minus f of 1 over x minus 1 as x approaches 1. F of x is x squared, and f of 1. You can plug it in, but it's been given. And again, I told you before, you don't have to be given the pair. If they give you x, you can plug it in and find y. So you have that. And I hope you realize if you plug in, you get 0 over 0. And the technique is factoring. The bottom is given. The top is a squared minus b squared, x squared minus 1 squared. So it makes it x minus 1, x plus 1. These two cancel each other. And now the limit of x plus 1 as x approaches 1. If you plug in, you get 2. And this is the slope. Now we have the slope and we have one pair. Y minus y1 that means y minus 1 happen to be 1, both of them, is m, which is 2x minus x of 1, that means x minus 1. Now you distribute, you get 2x minus 2, remove the negative 1, you get y equals 2x minus 1, and you're done. And again, it's really good practice to plug in the pair when it works. This part has been done, right? Has got nothing to do with this one. We are done, but I'm going to do the second method because actually this is more popular, but you have to know both of them. And so replace the a with 1. The limit of f of 1 plus h minus f of 1 over h as h approaches 0. So what is f of 1 plus h is 1 plus h squared. What is f of 1 we already know. And so all you have to do, square this one. You want to simplify this expression, okay? So this is 1 plus 2h plus h. One and negative one cancel each other. Factor the h in the numerator. Now you can get rid of it. Remember, again and again and again. The 0 in the denominator is a problem, so you're hoping to get rid of it. So you go through all these processes and you use your algebraic techniques to get rid of it. And so we do that and we get the same answer. Of course, I'm not going to go through that, but the point is both ways must give you the same answer. You don't have to do both ways. You do the way they ask you. We are going to look at one more example of that. Find an equation of a tangent line for this function at this pair. Again, even if they give you x, that's good enough. For example, let's say they said x is 25, then y becomes 5. In this case, of course, a is 16, f of x is square root of x. So we are going to find the slope. And again, I will do both ways for practice. So this time I'm going to start with this one first. And we need to find m, which is f prime of 16. So we replace the a with 16. Now what is f of 16 plus h is square root of 16 plus h. What is f of 16? You can use 4 or just leave it as square root of 16. On purpose, I want to leave it because what if it wasn't a perfect square and it wouldn't come out? I want you to know that you're looking at, if you plug in 0 over 0, and the technique is the conjugate because you're dealing with a square root. So if you change this negative to a positive, you put it up here and down here, and then first of all, this expression is 1 and it's absolutely acceptable. Secondly, this is the conjugate, and therefore a minus b, a plus b is a squared minus b squared. The square root of 16 plus h quantity squared minus square root of 16 quantity squared, which is the following. We can cancel out the 16 and negative 16. And again, we were always looking to get rid of the h in the denominator. Now we can. So when you do that, now you can replace the h. This is 16, which is 4. This is 16, which comes out as 4. So you have 8. 1 over 8. Y minus y1 equals m times x minus x of 1. So y minus 4 is 1 over 8x minus 16. And This is 1 over 8 times x minus 16 over 8 over 2. You move this one and you make it positive. So y is 1 over 8 x plus 2. You're done. However, I want to look at this method also for practice. M or f prime of a is the limit of f of x minus f of a over x minus a as x approaches a, and a is 60. What is f of x? Square root of x. What is f of 16? 4. If you plug in, you get 0 over 0. Since you have a square root in the numerator, the technique is to multiply and divide by its conjugate. What happens to the denominator? Nothing. You keep it as a product. What happens to the top? This gets squared up, comes out as x, and minus this gets squared up, 16. And now we can drop the common factor of x minus 16 from the top and the bottom. So we are left with the limit as x approaches 16 of 1 over square root of x plus 4. When we plug in, this becomes 4 and 4, 8. Again, we get 1 over 8, and that's exactly what we got here. And that's the second method with the same answer as expected.